Right, students? So far we get an introduction to solving equations, and we understand how to solve a simple equation, right? We continue with solving simple equations, but we learn a new technique, a new law, right? And this is how it is going on, right? So, for example, we're gonna look at three cases here, right? Number one, we have x add 2. Number two, we have x take away 2. And number three here now, we have 2x, right? So look at the three questions here I give you all, the three expressions I give you all here, right? I can make it in the equations. So I can probably put x plus 2 equals 10, x take away 2 equals to 10, and 2x equals to 10, right? So let me see what's going on in these three examples here. So far, we can say the first one is using the first law to solve this equation, right? When a variable has a number added to it, 2 is being added to x, right? Good. To solve for this variable x here, we do the inverse operation on the other side of the equation. So the inverse of adding 2 is subtracting 2. So x is equals to 10, subtract 2, x is equals to 8, right? X is equals to 8, and this is the solution to my equation here, right? So when I say solution to the equation, x could only take one value, which is 8. Can't take anything else. X equals to 8 makes this statement true, because 8, if I was to replace this x here with 8, right? I was to roll off this x here and put 8, 8 add 2 equals 10. That is true, right? Next. Good. We're looking at the next one now, right? So we say the next one is x take away 2 equals to 10. When a variable has a number subtracted to it, right? Good. So 2 is being subtracted from x. We're going to solve for x here by doing the inverse of subtracting 2 on the other side of the equation, right? Good. So the inverse of subtracting 2 is adding 2. So 10 add 2, x equals to 10 plus 2, right? X equals to 12. 12 is the solution to the second equation, and 12 makes the solution with this equation true. It makes the statement here true, right? 8 can work over here because 8 take away 2 is not 10, right? No other number could work there. The only thing could work here right now is 12, because 12 take away 2 equals to 10, right? Nice. And we understand those two laws very well. The third law we're going on to now is a bit different. It does not deal with adding and subtracting. It deals with multiplication, right? Something is being multiplied by a variable, right? So we're going to do a little recap on this too, just in case we need a revision here, right? Revision is always good, right? So let's just say, how was the term 2x derived, or even 3x, or even minus 2x? How was this term derived? Well, 2x was derived by taking 2 and multiplying it by x. Or we could have also said x multiplied by 2. X by 2 is 2x, or 2 by x is 2x. 2 here is called the coefficient, right? What is the coefficient? The coefficient is when a variable has a number being multiplied by it. Up here in this first case here, 2 is not a coefficient, 2 is a constant, right? 2 is by itself, basically. It is being added to x, right? Second case here, 2 is a constant, not a coefficient, right? Being subtracted from x. Good. So only when a number is being multiplied by a variable, we call that number a coefficient, right? In this case, 3x is the term here, 3 is the coefficient, x is the variable. And this was derived by taking 3 and multiplying it by x, or also it could be derived by taking x and multiplying by 3, right? Good, because we know in multiplication, right, the order doesn't matter, right? In multiplication, the order does not matter. For example, 2 multiplied by 3 is the same as 3 multiplied by 2. 2 times 3 is 6, 3 times 2 is 6, right? And this property is called the commutative property, right? Good. So same thing for here, minus 2x. Sometimes you might say, okay, minus 2 here is being subtracted from x or added to x or something. No, right? You see, this is being attached to the x here, minus 2x, minus 2x. So the coefficient here is what? Not 2, but minus 2. Minus 2 is the coefficient, and x is the variable, right? Are we clear with this? So this is minus 2 times x, right? Or x times minus 2, right? Good. And be careful with when you're writing x in algebra. X's, write the x's, right? Like this. multiplication sign, you might take normal x, and in algebra you tend to write the letter x with two c's coming together like this, right? So that's we're gonna mix up with them, right? Next. So look at this third scenario here now, right? What is being taken place here? X is being multiplied by 2, 2 is being multiplied by x, right? Good. But we know anytime we do anything to a variable, to solve the equation, we do the inverse operation on the other side. For example, we could see it clearly here that the inverse of adding 2 is subtracting 2, right? We could clearly see that adding 2 became subtracting 2. Same thing here, subtracting 2 became adding 2. So if x is being multiplied by 2, in this case, as you can clearly see here, right? X is being multiplied by 2, 2 is being multiplied by x. To solve for x now, we're going to do the inverse operation on the other side. So we say x is equals to what? What is the inverse of multiplying by 2, students? Anybody could say it? The inverse of multiplying by 2 is? Divide them by?
10 divided by 2.
10 divided by 2, right? So the inverse of multiplying by 2 is dividing by 2. So x is equals to 10 divided by 2, right? But you can write it like this as well. I prefer to write it like this, right? 10 over 2, right? So you can cancel off or you can leave it as a fraction, right? But in this case here, we could say now x is equals to 2 into 2, 1, 2 into 10 is 5. 5 over 1 is 5, right? So 5 is the solution to this equation here, right? We could clearly see 5 is the solution to this equation here, right? 5 is the solution to this equation here. 2x equals to 10, x equals to 10 divided by 2, right? X equals to 5, right? And we see we did the inverse operation on the other side. So far we dealt with 3 operations and we did the inverse of those operations to solve for the equation, right? So we can have a little table here now, right? So if you have a little table here, we could talk about operations and their inverses. So you have 3 operations we talk about, right? Addition as in the first example here, subtraction and multiplication. And the inverse of those operations, the inverse of adding is subtracting. The inverse of subtracting is adding. And the inverse of multiplying is dividing. Okay? And we want to state this rule officially, right? So don't write it, I'll give you a chance to write. Right? Make sure you have everything done, right? Revision is always good. So that is why I do have a revision here, right? Next. So this third law, we have a little space here, so I want to flip it here, right? Make sure I write it neatly in all the books. And what to pay particular attention to, students, as mathematics students, right? Make sure and space out your work nice, right? So this example, skip a line, then do a next example, skip a next line, do a next example. If you do need two on the same page here, right, side by side, make sure you skip enough page in between here and skip enough page in between here, right? One line is going to skip 2 lines. Make sure your work is neat as possible. So it's easy for your teacher to correct. It's easy for you to see if you make any mistakes, you can follow back your steps, right? So if your mistake is in this line here, it's easy to spot. It's easy to spot in this line here. You can do the correction. You have space to do the correction here, right? Point to note also, right? You see how you're going downwards in mathematics? This is one line, next line, next line. All this is one question and we're going downwards. Pay particular attention to all the steps we're doing here, right? To solve our equation, right? Good. So this law here, we can take this law here, right? To solve number 3 here, when a variable has a number multiplied by it, right? To solve this equation, what we just do? We divide that number on the other side of the equation. EQN is short for equation, right? Nice. So it's enough fit in here, so that's good. And this is a law 3, by the way. We just call it law 3. It don't have a specific order for these laws, but I just call it law 3 for me to understand what we're doing here, right? Good. And we realize we don't need to know them laws. All we need to do is understand what is being done to the variable and do the inverse on the other side, right? Keyword inverse operation. And we see 3 examples of that clearly here, right? Good. In the first case, the inverse of addition is subtracting on the other side. The inverse of subtracting is adding on the other side. The inverse of multiplying is dividing on the other side, right? So this is the one we're going to practice more today, right? And probably next week I could give you a mixed exercise, meaning mixed exercise that we're going to get a set of questions and we're going to decide which law to use, right? But before we do that, we're going to perfect this third law here, right? Because over the last two classes, we dealt with the first two laws already. So go ahead and take this down, students, and we're going to do some more examples and we're going to get some practice as well, right? So let's look at some more examples, particularly for this third law here, right? So look at this one here. We have here 3x equals to 12. What is being done to x here? X is not being added to 3, subtracted, no. Nothing but multiplied, right? 3x here, we have the coefficient 3 here, right? So just to recall, 3x is, think about this in your head, 3 multiplied by x, or x multiplied by 3, we know, same thing, right? Nice. So we're going to do the inverse of multiplying by 3. Students, what is the inverse of multiplying by 3? The inverse of multiplying by 3 is dividing by 3. So we're going to say now x, to solve for x here now, we do the inverse of multiplying by 3, which is dividing by 3 on the other side of the equation. So x is equals to 12 divided by 3, and 12 divided by 3 is what? 4. So 4 is the solution to this equation, right? Yeah. Next example we're going on to here now. 5x equals to, let's say 20, right? X here is equals to what? To solve for x, we're going to do the inverse of multiplying by 5 is divided by 5. 20 divided by 5, 20 divided by 5 is what? 20 divided by 5 is 4. 5 into 5, 1. 5 into 20, 4. Right? We have plenty more examples to go, students, right? So let's say here now, okay, 2x equals to 13, right? What is being done to x here? X is being multiplied by 2, right? So the inverse of multiplying by 2 is not taking away 2. That will be wrong. The inverse of multiplying by 2 is not adding 2. Wrong also. So we're going to divide by 2, right? Divide by 2, right? If it was x add 2, then we could take away. If it was x take away 2, then we could add, right? So here now we could say x is equals to 13 divided by 2. What is 13 divided by 2? 13 divided by 2 is simply 13 divided by 2. Right? Can't get exact answer here. But we know from before that this is called a improper fraction. Right? So if you wish, you can convert this to a mixed number. Right? But as we learned in primary school, so we see now 2 into 13 is 6. We mean that 1. So this is 6 and 1/2. Right? Nice. Right? So this is how we just do questions like these. Right? Nice. So again, example again here. Right? 6x equals to 15. We want to solve for x here. Okay. What is being done to x here? X is being multiplied by 6. Right? So we're going to do the inverse of multiply by 6, which is divided by 6 on the other side of the equation. So we say 15 divided by 6 is the answer for x. Right? And when we divide 15 over x now, we can use cancellation. Right? Because 6 cannot go into 15 equally. Right? It must be a remainder of some sort. Right? So we look at the cancel. And we realize here 3 could go into both numbers here. So we can cancel up 3. Right? 3 into 6 is 2. 3 into 15 is 5. So x is equals to 5 over 2. Right? To be more specific, this is an improper fraction. Right? Can't cancel further, but we could convert it to a mixed number. 2 into 5 is 2. Remainder 1. So this is 2 and 1/2. Right? So we're going good here. Right? Nice. We're looking at some more examples here, students. Pay attention. I'll give all a chance to write after. Right? Nice. So 9x equals to 7, or let's say, okay, 9x equals to 3. Okay, 9 is being multiplied by x here, so we're going to divide by 9 on the other side. Let me tell you what's happening in this case, students. Some students think, okay, we do like to put the bigger number, the smaller number, and divide by the bigger number. So what they want to do here, they want to say, okay, this is x equals to 9 divided by 3. That's totally wrong, right? We can't say 9 divided by 3 here. Why we can't say 9 divided by 3? Right? Because I get us a lot. Some people think 9 divided by 3 is the answer here. This is not the answer, right? What is the answer here? X is being multiplied by 9, so we're going to divide by 9, right? X is being multiplied by 9, so we're going to do the inverse of multiply by 9, which is to divide by 9. So x is equals to, the right hand side doesn't change, as we learned from before, right? Positive 10 remain positive 10 throughout, right? The 10 remain 10 throughout. If it's negative 10, it remain negative 10 throughout, right? So what we need to be careful with is the right hand side. We don't want to change that at all, right? So this is 3 divided by 9, right? It's okay to get a fraction as the answer. Fractions are answers, normal numbers, right? Okay to get fractions as the answers, right? Most of the time you will get whole numbers as the answers, yes, but expect fractions sometimes as well, right? Good. So the inverse of multiplying by 9 is not divided by 3, but divided by 9. So we say x is equals to 3 divided by 9. And we could cancel here, yes. 3 into 3, 1, 3 into 9, 3. So the answer here, final answer is x is equals to 1/3, right? Good. Yeah, so we saw one more example. So let's look at this one here now, right? So we could say, okay, 17x equals to 6, right? 17 is being multiplied by x, right? Good. You could go in your working column and let's recall 17x is x by 17 or 17 by x. The inverse of multiplying by 17 is divided by 17, right? So don't come and put 17 over 6 because 17 is a bigger number. It doesn't deserve to go on top. No, right? Because we multiply by 17, we need to divide by 17. So x is equal to 6 divided by 17. And guess what? What again I just get from students? Besides the tendency to put the bigger number on top, to divide by the smaller number, right? What else they want to do is they want the tendency to convert fractions one time into mixed numbers. That is good. But this is a proper fraction because the numerator is smaller than the denominator. So x remains 6 over 17, right? Because 6 divided by 17 is 2, remain a 5, 2 and 5 17s, or whatever the case is, right? You can't do that, right? Or 2 and 5, 6 or whatever, right? No, you can't do that. This is a proper fraction. Your answer remains as a proper fraction. So you can leave the answer as x equals to 6 over 17. Cannot be converted. Proper fractions are what it is. Proper fractions. It's like x is equals to 1/3. This is a proper fraction. Right? So proper fractions, we leave them as is, right? So you have enough examples to take down here, students. Take this down now, right? Right. So just like how we used laws of directed numbers when we solving equations involving signs with the addition and subtraction laws, right? Now we're going to recall the division and multiplication laws of directed numbers now when solving equations of this type, right? So I'm going to explain what I mean by that now, right? So when we did directed numbers, we did the following laws, right? Laws were a positive multiplied by a positive is a positive, right? A negative times a negative is a positive, and then a positive by a negative and a negative by a positive. When I say by, I mean multiply or times, right? Both produce a negative result, right? Nice. So these are the 4 laws we learned of multiplying signs, right? And these laws and them are same for division. Same for division. So when I say same for division, right? A positive divided by a positive term produces a positive. A negative sign divided by a negative sign is positive, and same goes for the rest. Positive divided by negative, negative, negative divided by positive is negative, right? For example, negative 3 divided by negative 3 is positive 1, negative 5 divided by positive 10, right? Negative divided by positive is negative, right? Negative 1/2, right? And what again? Now we do the next example here. Negative 20 divided by positive 4. 20 into 4 is 5. Negative divided by positive is negative, right? Good. So this is a study revision of the laws. You know these laws already, right? We did this in detail, right? Nice. So let's look at some examples now of solving equations using this last law we learned today. And in addition to that, we're going to incorporate the laws of directed numbers, right? The signs and them, right? Nice. So let me look at that here now, right? So for example, if we have here 2x, negative 2x equals to 6, right? Ask yourself, where negative 2x come from? This was derived by taking negative 2 and multiplying it by x. So -2 is the coefficient here. So when a variable has a number multiplied by it, I look back at the law. It's not the law is here. When a variable has a number multiplied by it, we divide that number on the other side of the equation. We divide that number. So the number here is -2. -2 is being multiplied by x. So we're going to divide -2 on the other side of the equation. So you're going to say x is equals to 6 divided by -2. Right? 6 into 2, 6 divided by 2 is 3. Right? 6 remains positive, of course. Positive divided by negative is negative. 6 over 6 into 2 into 2, 1. 2 into 6 is 3. So this is -3. -3 is the answer for this one. Right? Going again to the next example here. Right? -3x equals to -18. Right? Good. -3 is being multiplied by x, so we're going to divide. Right? Good. Take note, students, this is not x minus 3 equals to 18. Right? If that was the case, then you add. No, it'd be multiplied. See the difference here, right? -3 is attached to the x. -3 is the coefficient of x. It is being multiplied by x. So you're going to divide by -3 on the other side. So you say x equals to -18 divided by -3. -18 divided by -3. Look at the laws here, right? Laws of multiplication, same laws for division. Negative divided by negative is positive, right? And we say 3 into 18 is 6, right? 6 over 1 is 6, positive 6, or we can just say x equals to 6, the positive is understood, right? Good, so let's go on to some more examples here, right? So let's say you have, okay, what? 8x equals to -24, right? Good. 8 is being multiplied by x. So x equals to -24 divided by 8, right? X is equals to 8 is positive here, of course. It is positive here and positive here, right? You can put it in if you wish to. You don't have to put it in. Or you know, negative divided by positive is negative. 8 into 24, 3. -3 is the answer, right? Good. Example again here now, right? Let's say -4x equals to, let's not. Space on the side here, right? Put on next example, right? -4x equals to 16, right? X equals to 16 divided by -4, right? Good. Negative over positive is negative. 4 into 16 is 0.41, 4 into 16, 4, -4 is the answer, right? I kind of get it pretty, you know, right? Nice. Let's look at the next example here now. Let's say let's say -15x equals to 3. What we're going to do here? -15 we multiply by x, so we say x equals to 3 over -15, right? Good. So what we need to do here, first of all, pay attention to this one, right? 3 into 3, 1, 3 into 15, 5. So the answer is 1/5, right? But we're not going to put back these two signs. It makes no sense because we divide any sign, we could get one fixed sign now, right? The answer is a fraction, yes. No problem there, but a fraction could only carry one sign, right? So positive divided by negative is what? Ask yourself that question. Positive divided by negative, positive divided by negative, positive divided by negative is negative. So -1/5 is the answer. We have space for one more example. So let's say I have -8x equals to -3, right? X here is equals to -3 divided by -8. This is a proper fraction, right? And negative divided by negative is positive, so the answer is +3/8, or just 3/8, right? Next. So we understand now how we can incorporate the laws of directed numbers in solving equations, specifically this law here, right? So go ahead and take this now, students. I'll wait for you all and have some questions for you to try, right? Right, so now that we understand everything we did today, we understand these three laws now. The third law, the latest law we did today, right? These are a little word in here to describe the law, and this table summarizing what we're going to really do when we solve equations, right? Once you see one of these operations be done to the variable, do the inverse on the other side, right? Nice. You see some examples here, simple examples. Some examples here involving the signs, right? And then now we have a little exercise to do here. So this exercise here, you all will do this homework. Make sure to look back at the examples, be careful of them, right? And next day we're going to correct this. And I'm going to give all your exercise. Well, we're going to do some more examples, a final revision on this, and then I'm going to give all your exercise involving all three laws mixed up, right? So you're going to have to determine which law to use. So make sure and revise the law properly and Any problems, or you could just let me know, right? Good. So, well, if I finish this down, I could leave, and I'll see you in the next class, right?